first of all, does everybody understand what we're talking about when we're talking about the valve lift of the engine? We go back to basics. Let's go back to basics a little bit. Camshaft. Stick with some lumps on it. So this shaft goes around, obviously, half speed with the engine, and the lumpy bit of the camshaft is what makes the push rod go up and down. There's a follower that sits on top, and then the push rod comes up, goes through the rocker, and pushes the valve down. Now, the camshafts are controlled, so the distance between the back of the camshaft and the top of the camshaft, that relationship is a controlled distance. So, in all of the engines that you have, if it's a logged cam and it's the right one, that should all be the same. Now, logic would say that you would think, well, if that's the case, why doesn't you're only pushing up here and around the corner and down? Why doesn't the valve go up and down the appropriate amount? But the reason why it varies is probably threefold. It's not the camshaft, because that's a control part. There's a push rod, which the length of that is a production item, so they're not all exactly the same, the length of the push rods. There is a small variation in those. The biggest problem is the fact that these pedestals are just attached with a bolt, no doubt, so they can move this way a little bit. And the rocker itself, this part, I'm going to put the glasses back on. The rocker itself has got a pad on it. You can all see here, there's a push rod pushes on here, and there's obviously a relationship between that centre, this centre, and where it's touching. And you can see on this shaft in particular, these rockers are not actually all the same. See this one has got a little black bit on the outside here, and this one is right on the very edge. This one is pretty much on the edge. Come back to these ones, that one's not very good. I mean, this is just a standard one. Right. So it's pretty easy to see that these are not actually all the same. Everybody see what I mean? And this one in particular is touching, yeah, it's not the same. So, I mean, if we were pedantic and we tried to measure that, it would be quite difficult to do, but we'd find that it was not the same. So what you have is you have a rocker here, pushing up on this piece, but where this pad actually touches on the valves is not necessarily the same as on the side of it. And it certainly isn't in a place that's going to make the valve move as close to the maximum limit that's in the book. If you put this shaft that's unmodified on the engine, the measurement we're talking about is 9.1 millimetres. I'm pretty sure that's what it is. 9.1 millimetres. These are probably only 8.5. If I bolted that on there, it would probably be 8.5 millimetres. So I mean, from a racing point of view, we want to try and optimise all of these things. So 8 times half a mil extra valve lift could turn into a bit of damage. Like all of these things, if we don't optimise it, then we don't know what we're losing, do we? So the centre of this radius here, if I turn the engine over, which is just, if I turn the engine over, try and turn the engine over. Turn the engine over, you can see here how this rocker is touching the top of the valve a little bit past the centre of the valve. If I rock it back this way, you can see that when it's in that position, it's actually rocking pretty much on the very back side of the valve. So where this radius is in comparison to the centre of this is what changes the amount of valve lift we're talking about. So you're essentially changing the length of this pivot in relationship to this pivot. So you might say, well, how do you do that? Well, the way to do that is you have to disassemble all the shaft, and you have to put that on a machine that can radius that, and you can move that radius away from the centre, like that. You can move the radius that way, and you can move it back this way. And that's how you do it. I mean, you need a tool, and you need a jig and a machine to be able to do that radius. It's not something that a normal engine reconditioner would ever bother with.
You're talking about
the radius
on the rocket.
So what I'm saying is you need to be able to, and we've obviously got a machine that does it, you need to be able to put this up against a grinding stone and take this radius here, probably have a board, we'll have to take that radius and move it out there, or move it back that way. Okay? That radius you can see with that, the centre point of that, where it touches the well, needs to be able to be moved this way or that way. And you can only do that precisely with a machine that holds the rocker and radiuses it around a stone like that. Okay. Now in the early days, when I first started doing Ford, we used to do it by hand, with this grind. And people probably still do it today. And if you're careful, you can do it and get right to the very limit, no problem. But because you're doing it by hand, and it's a bit mixed, it tends to be quite unreliable. So I would suggest to you that if you are all aligned to do it that way, and a lot of people still do it that way, you'll find that you'll need to be checking the valve lift constantly, even during the meeting. It could move as much as 0.1, 0.2, because instead of having something which is rolling on the top of the valve like this, you've got something that's wiping. So you've got a point loading, which you're moving that point back. Well, a lot of people used to do them just in a V, like that, with a little radius, so they can move that point further away or not. Whereas the trick is to take the radius and move it out, so that there's a rolling motion, so then that reduces the amount of wear, because it's not rolling on a point, it's rolling on a radius which is actually geometrically correct. Okay. Is there any questions on what we've done so far? I'm sort of brushing over it a little, but and you can even see on this chart how worn those are. And that's the factor one.
They each need to be shaped individually.
They have to be each shaped
individually. Each one,
yep.
And you move them around to suit.
And it even depends on the machining tolerances on these.
Number them carefully.
Yeah. They do have to be done.
Still being reasonable.
Do vary a little bit, and all that is just a ratio, depending on where they are. Now you can see this engine. See this engine here, got some spaces under these bolts here. Generally, I mean those spaces are not generally used, and they are on this engine for a reason. And the reason for that is that this block will be needed to a point where you couldn't get the action of this to operate correctly. So what they've done is they've lifted the whole thing up because the push rods are too long for this particular engine decline. I mean, it might have been decked off 3 or 4 times as a road car, and then whoever built this engine, because it's not one of ours, it's just something we're laying around, might have had a mile and a half on it, and that's why there's a mile and a half space around here. It's not really the way to do it. It's better off to start with a block that's the right size.
They're more inclined to move on the bulk end.
Is that a problem? Yeah, it is a problem because that affects that distance is critical.
Can the blocks be dowelled into the...
Technically not allowed to dowel, but what you can do is you can replace these bolts with a stud, and that is a better option, a stud and a nut. And that is a good way of doing that. I mean, a bolt going into an aluminium head, I mean, when they were cast iron heads, it's not quite such a problem, but now we're using aluminium heads, the threads start to get a bit tired after a while, and especially if you're taking them on and off all the time. So it's important to perhaps address those things depending on if you're an engine builder that does it, or if you're doing it yourself, which a lot of guys are doing these days, which is quite a good thing. Then it can be a lot easier to set that whole rocker shaft up when there's studs in here and not holes. Any other questions before we actually have a look at how to do it?
So what do you try, what's the optimum actual rockers? Do you want them sitting flat or no lift? Do you want them sitting this way?
Well, you're a bit stuck because you've got a block, you've got a set big push rod. I mean, if it was a V8, you can buy the push rods in 16-inch increments, and there's a set place for this to be as far as the rocker geometry is, because generally they're rollers. In Formula Ford terms, you want to try and have these sitting pretty much where this is sitting, but without the spaces. So it's not as critical in this type of thing, but the radius on the end of here and how that operates on the top of the valve is. The moment you get a wiping situation on the top of here, you're going to start to wear the top of this radius away, and you're also putting a side load on the valve. It's going to wear the guide out, which you really don't want to do. So, obviously the spring tension is something that people have got different ideas on as how much that's going to be. It doesn't really seem to make a lot of difference as far as the wear and tear on the rockers and things. It's a pretty robust thing, and it generally, I mean, there's the odd time you'll break one of these, especially if they're old. They'll break and split down the backward. But generally, pretty unusual to break a rocker. These nuts here are a deformed thread, so they're stiff in the threads. One thing to be quite careful of is as these cylinder heads get decked down and the blocks get decked down, you get a situation where these aren't screwed in very far. So they tend to be quite loose, and there's not a whole bunch you can do about it other than change this or change that and find one that is going to be okay. You can't buy them new anymore. So that's an issue. But they're a deformed thread in here and a very flat type of thread on this steel drill.
Did you buy rocker shafts new?
I've not been able to, no.
So what's an acceptable wear limit for the rocker on the shaft? Say if you've got an existing.
I mean, it probably doesn't make a whole heap of difference to the performance of the engine, but it would make a bit of a difference to things like oil pressure and how fast it's going to wear again. Because if you've got a shaft that's not actually round anymore, it's just built on the bottom, then it's going to continue to wear in that point because it won't get any oil in there because it can't be supported by the rest of the radius. So, I mean, have a fish through some old shafts, find the best ones you can, turn it upside down if you need to. I mean, that's not the best way to go about it, but better to try and get, I mean, there's plenty of shafts out there that are in quite good condition. And all these parts are not available necessarily, but they are readily available if you look for them or bring us up.
So your push rods would be individually marked?
It's good, yes. Yeah, it's a good idea to put a scratch on them. So, because if you were to pull it apart at the track and put it back together again, you need to be pretty sure that it's going to go back and not be different to what it was before. So keeping it all together is quite important. And the other thing to be careful of is things like this here. These clips here, the way that's just been put together. I mean, it's not our engine and we haven't put it together, it's just the same. So generally you'd cut those clips off a bit shorter than that because the vibration one of these days, one of those is going to snap off, it's going to go down and you pull it down the bottom somewhere, maybe the engine doesn't have a gauze in it, and then scatter side will pick that up and stop the pump and the whole thing will be a mess. Doesn't take much. So one of those clips will stop the oil pump and half back. If it didn't have a gauze, it would stop it from doing that on this side. So I mean, that's something that if you are pulling an engine apart, and we've digressed a little bit right now, but if you pulled an engine apart, your own engine for example, and you found there was no protection in the sump for any foreign bodies, as in a gauze on the scabbing side, I would put that back together like that. Make the coils up, put it in, get one off us or whatever, change the sump, whatever you have to do. prone to those little things happening, so you might have some sort of insurance. So the TOs tend to do an indicative test on the valve lift, and the indicative test is to put the valve on the back side of the cam. So this is obviously the high side, this is the low side. So put the valve on that side, so there is some valve lash. Get a feeler gauge which is the right size feeler gauge, so it's just a nice fit in the clearance, and then check the valve lift. And if you think about what I just said, what's the main difference between that and the operation of the valve when it's in motion? Any ideas? Huh? We've got no clearance, but we've got no clearance because of
Got the movements of the arc and
you put something in there. So you've got a rocker like this that's going to come down on top of the valve. In its normal operation, nothing in between. So the angle of its relationship from where it pivots is going to be different. It's normally going to hit there, and then it's going to hit here. Bearing in mind the rule says as run, so they're going to check it as run. So then what they will do is they will close the clearance up. Is the other way, which is the pucker way that they say that's the indicative, not the indicative, it's the final way they check it. The indicative way is to put the feeler gauge in because they don't have to change anything. They just put the feeler gauge in and check it. And if it was 8.7, they wouldn't check it the other way. But generally there could be 0.1, 0.15 difference sometimes between the two methods.
I've never had it done with the feeler gauge. I've always done areas
Closing it up.
Yeah. And that's the TO's discretion. I mean, they can't do it with a feeler gauge and then go, oh, it's 9.4 and chuck you out. They can't do that because the book says it has to be done this way. But at the track, some of the TOs with a lot of experience know that if they do it that way, they can quick check it and go, yeah, we're happy with that. There's not really any way of cheating that because it's a reasonably known difference between that method and the other method. Okay. So does everybody know what the other method is? Okay. The other method is to put it on, to have it in the same place on the back of the camshaft and wind the adjuster down until you just can't touch or can't turn the push rod. So you take the lash and take the clearance out. So at the moment, that push rod is that push rod turns. See that? Quite happily. So we wind that down until it won't turn anymore. So basically it's hitting hard on top of the valve here, it's hitting hard on the top of the push rod, on the follower, and then onto the back of the cam. Now it is possible, and the camshafts that are being ground these days actually have a bit of a low spot in them between this point and this point here. I mean, they shouldn't have, but the master that they're using has got a funny low spot in it. It doesn't make any difference to the running of the engine necessarily, but it does make a bit of difference to where you check it. So you need to be a little careful that you don't check it in the hollow, set it in the hollow. Okay. So be a bit careful that you don't run it too close. You'll notice that if you set it up and go to check it, you'll notice a thou or two difference. A thou is not making a difference to you. But the cams are not 100% the same diameter from there all the way around to there. Technically they're supposed to be that way. Right, that will go on. What we'll do to start with is we need to have one of these in the box. So we need at least a half-inch stroke or 12.7 mm stroke DTI, and you can do it by using a metric one or an imperial one. So we can do it in thous or in metric, doesn't matter.
So the TOs have the other one that bolts onto the...
They have one that does what's it? Oh, they won't have one that bolts on. This way. Okay, so essentially, you make yourself a plate and you can buy a standard one of these, standard one of those. It's pretty simple. Okay. So, the trick is here, and what we'll do is we'll do it without changing the lash at all. Okay. So, need the clock to be able to read here, and move both ways. Set this round to 0. Go to the spanner so I can turn it from this end, it'll be a bit easier for you guys to see.
There's the arm for not a tripod. No. I don't think so. It makes some connections. Yeah. It's just a phone profile, yeah.
Okay, so which way does the engine go?
Anti-clockwise.
Okay, so it doesn't matter?
Yeah.
Does it? Why does it matter?
They normally push the car front.
Would the lift be any different if the camera's going that way or going that way? No. What is different is that in the front of the engine where the little pad chain tensioner is, it's got a little ratchet scroll in it. If you turn the engine backwards, there's a potential for it to tighten up and then it will wear really quickly. So it's a better idea to keep the engine going the wrong way.
Which is the same, yeah, like when they push, you always do it when they're pushing the car, don't they?
Yeah, which is this one. The easy way to remember that is if you screw this nut up, not undoing it, because it's going to come undone probably, then you're going the wrong way. So you can see there that valve's gone down, right? So that's the way it works. So you need to move this now down until you've got 0. Down to 0. Round 0. And all going well, when we wind this around. And bear in mind I haven't changed the lash yet. So we'll just count this as we go round. 1, 2, 3, 4, 5, 6, 7, 8. And then good idea just to check that the clock will go past that. If we ran out of travel on the clock, it would be a bad reading. Okay, so that says 8.53. So we've got no lash there at the moment. Right, so we'll come round. Come round. Very quick way of knowing when these two are in their firing position. This firing, which is where it would be on the back side of the cab, is that these two here, see that? These two. So when these two here are rocking, I'm going to try a really simple way for you to do this. When these two are rocking, you can check those two. When those two are rocking, you can check these two. When those two are rocking, you can check those ones. When those two are rocking, you can check these ones.
Does this apply to that rule of 9? Do you use that?
Yeah, the engine guys do use that. In the field, you can use that too. I mean, if we look at this camshaft, for example, if you look at back lobe, the back one, and we're on the the very back of it from there. This one is at the top. Okay, so this one has got full lift, this one's got no lift. And it has the potential to be a little lower here because of what we've said about the cam not being absolutely round. Okay? So the correct way to do it, if there is a correct way, is when this one is at full lift, that one will be at what would be considered the opposite of full lift. So number one, and row. Okay. A very easy way to check it is by doing it. These two, those two, that one, this one, that one, that one, that one. So now we've got a situation where we've got that measurement, and if we put a feeler gauge in here, take a step and go. Obviously not warm enough in here. Let's go 6. Now, if we go back to this point. See how it's changed? See how the position's changed? We're now not on 0, we're now on half an omelette. Come back and put this on 0. And go out. I don't know whether you can count that fast or not now. Pretty close to 0 here now. So, 1. 6 now, see? Now we've got this thing. Right, so now we're at 9 millimetres, just a little bit more. So it's a big effect. It's more than the 6th hour. And that's because of the fact that it's coming around like this so far. And remember, of course, that there's a ratio between that distance and this distance. So if this moves, let's say, that ratio might be 1 to 1.8, so 1 to 1.3. So if this moves 10th hour, this end's going to move 25. Some relationship. I don't actually know what the actual relationship is. It's a bit irrelevant because we're stuck with some parts. So what we're trying to do is get to a point where we've got, say, 8.95, something like that, the number that you're comfortable with. Is it 9.1 or 9?
I think it's 9.1.
9.1. So you probably look for 9, 9.05.
Well, when they get right round to the, just before the one in the top bit here.
Okay.
What's the normal valve carriage?
Pardon?
What's the normal valve carriage?
Minimal. Well, aluminium head somewhere around coal. What we're doing now, somewhere around the 6 mark. For an inlet. And a little bit more than that for the 6 mark. Just to allow for the growth of the head. Because aluminium as it warms up will grow about 1/4 per inch generally as it warms up. So potential for this face to be 4 or 5 thou higher than it was when it was cold was quite high. It makes a big difference on aluminium block engines. I mean, there's a slinger down there, and you can tell apparently, I don't know, we haven't done it, but apparently when they warm up, the belts go twing tight and they almost loosen up to fall off. Okay, so now let's just take a lash out. So I can still turn that with my finger, but that means that there's still just a little bit of lash there. Now it's gone tight. Okay, so that's now what I consider to be dead tight. Just try it exercise. Just try and turn that push rod and you'll see how tight that needs to be. Okay. You can just turn it, but it's clear there's no thing. TO point of view, they just needed to have 0 tests. Right. Okay. So we'll go back down to the bottom end. Now we can do this actually. Go back down to 0. I'm probably doing this backwards, so I might change that.
You measure from the bottom up, is that the reason?
Well, no, I'm not actually. I'm actually measuring from there down.
Yeah.
Okay, so we're on 0 there now. So none of that's changed because we haven't actually pushed the valve down off its seat. We just made it firm. So who's counting?
Nothing.
Sorry. So you can see there's a little bit of variation right at the very top. Now here's what that might be. Bear in mind they're going to take the highest number. But that variation is the valve clicking over the gone. That's where there's a round thing like this, and if it moves like that, it's going to go up. That's all it is. Okay, so now we've got 9 millimetres, and we have considerably different figures before. One thing you have to be very careful about is let you go back and check the 0. Because that might say 10 or 9, says 9, but if you come back here and it doesn't come back to 0, then that reading is not correct, is it? Okay. So we're there now. Now what we'll do is we'll just look and see what this particular account is like. If we think about this, we're going to go that one there, this fullness, so we're going to look this valve there, we're going to bring it back up. Tell me if that clock's moving. Does it move?
No.
It hasn't moved?
No. It's really
This pen's a bit better than some of them.
Yep.
And now, how much does it move?
0.2.
What the hell did I do it? Yep, you can actually see that moving. Look at that. Oh no, that's on the left. That's not that's further in. Go back the other way now. It hasn't moved, no, it's still in. I mean that can't actually that's how you would tell. Because you've got no clearance, so the foil is sitting hard on here. You come round to the back and then you come round quarter of a turn, which is only an eighth of a turn on the crankshaft, and then you go back a quarter of a turn on the crankshaft to come to jigs. Not something you need to get too carried away with unless you're trying to run down to a fair and a half or 0.05 away from the limit. It won't actually affect. You just need to make sure that you set the zero in the lowest spot, because the TO is going to take the largest amount. Okay. And that's as simple as it is. So it's not particularly difficult. But you do have to be quite accurate with the zeros, with the zeroing it, and make sure you've got a clock that is long enough. If you're going to buy a clock, I'd suggest you buy an inch stroke one. It makes life a bit easier. Because we're talking about 9 mils, and we've only got 12 mils of stroke in that clock. So buy a 25 mil stroke clock, you can sort of set it up pretty much anywhere, and it's sort of easy. I mean, they know the difference in price.
So, are they very fussy where they put the clock on the
Inside or the outside? They don't.
inside?
They don't tend to be just anywhere where it's convenient. I mean, that's not going to change. Not with the load that's on it.
John, when the TOs do a check, the engine's likely to still be warm. And yet when you set it up in the workshop, especially when you're doing the rockers, it'll be stone cold. So is there a difference between an engine cold and an engine?
Well, technically there shouldn't be, because you've taken the lash out.
Yeah.
But I think in real terms it probably is a small change. And I wouldn't be able to tell you which way it goes necessarily. But it's something that's worth checking when it's hot. I mean, we certainly check it when they're hot on the dial.
Yeah.
Piece of mind.
And there's a piece of mind. Now, I mean, the procedures, the boys set them up as close as we dare, which is generally within 2 thou or 0.05 from the limit. We run the engines in, run them, tune them, do whatever we need to do, and then we will check them before they come off the dyno. We'll change filter, cut the filter open, do a valve check, and then we're ready to go on the car. There's nothing else that you can check externally, make sure, but remembering that if you've done your job properly on the radius, which is actually quite difficult for guys that haven't got the gear that we've got necessarily, if you've done your job properly, there won't be any appreciable wear, so it won't change. If you do it the old way, you do it on the side of the disc grinder, on the side of the angle grinder, and I mean, there's no problem in doing it if you're careful and skilled at doing it, but you will suffer from the wear issues. And it's pretty hard on top of the valve as well. I mean, I used to do them by hand before we had all this flash equipment we've got now, years ago. But there's lots of things that we do with flash equipment now that we didn't used to do a long time ago. We never had a dyno even, so it was all, I think it's about half the time ago. So, I mean, that's the crux of how you would check it. It's the same for the inlet and exhaust, no different. And then, if you were unlucky, say for example something had changed or you mucked it up, and a TO went, oh, this one's 9.05 and 9.15, the rule allows for, well, I need to read the rule, but my understanding is you add up all of the inlets together and then divide them by 4, and if the average is under, then you're okay.
Yep.
But it's not adding all 8 together, so you couldn't have 2 big ones and then sneak it under the way. It's 4 inlets and 4 exhausts. So you add the 9.5 and the 9.5 and the 9.5 and the 9.5 together, divided by 4, you'd still be over the limit. You're out. So 9.12, and then the next one's 9.03, and the next one is right on the limit, right on the limit. You would sneak in by 0.01.5. And that's, that rule's come in simply to allow people to have a little bit of non-academics. And at the end of the day, the film is about people doing it in the garage. people are doing it, and it's great to see. Any questions? Now, I purposely haven't done anything about cam timing. It's quite a lot more involved, and it's probably not something that, unless you were actively building a complete engine, that you would need to get involved in. I'm happy to go over it in brief if you would like me to. I mean, we're not going to measure one, but I mean, essentially, the cam timing is something which is a variable you're allowed to do, and it's the position of the camshaft in relationship to the crankshaft. Now, cams are controlled, so the position of this load to this load is a controlled position, and its relationship with that one and that one and that one and that one are all controlled. But where you put this in relationship to the camshaft, to the crankshaft, sorry, is something that you have some control over, and it's an engine builder's preference. Now, standard they're put in at 109 degrees away from posted centre, and if you were to check maximum lift on this valve and maximum lift on this valve, then you would have, and set it standard, it should be at 109 degrees apart from the TDC. And you can turn it advanced, or you can turn it retarded. It's entirely your decision. There's no limit. You can turn it 5 degrees or 1 degree, or back the other way, or whatever. You can turn it a quarter of a degree, but you can run. So different engine builders have got different ideas about how and where they want to set that size, not a number that we can do with that. We do have clients that build the engines and then ask us to set the cam timing before. We're happy to do that at any time. And the same with this as well. A lot of people want to build their engine, but they haven't perhaps got the gear to do that sort of stuff, and want to do it really accurately. So they'll just build the engine. We don't need to know what's inside it, but we'll do that more technical stuff. So that covers the cam timing side of things. Got a few bits here that we're going to look at, which is okay. That's the gasket that we use. I mean, there's various other versions of it. That's the British Motorcraft gasket. It's much more constant thickness than the cheaper versions. Quite good in the fact that if you were stuck and you didn't have one, and you had to take a sling head off, you could reuse it. It's not recommended, but you can get away with it. I mean, sometimes Tio might want the head off it, and you need to run again that day or the next day, and you haven't got one. But very, very good gasket.
So, is there any variation between an alloy head and a cast head as far as the gasket goes?
No, same gasket. I mean, there are some variations between the cylinder heads and an aluminium cylinder head and the cast iron one. The valve spacing is different here, very slightly, to allow for the seats that are in here, cylinder head here. Obviously, these aluminium heads have got steel seat in them, so they've actually pushed the valve spacings apart slightly. Can't remember how much it is detailed in the book, but it's a little bit. It's not massive, but it is a little bit. I mean, it's not so much because obviously you'd have a problem with this being out of whack, so but that's quite common. All these cylinders have obviously got bronze guides in them. Standard, can have bronze guides, and perhaps a little bit of a word of warning is that if you had a aluminium cylinder head straight from the manufacturer, you want to be very careful with the valve seats and the guides. And without getting too carried away with it, they are not a particularly high quality item. So you could buy a cylinder head, quarter, bend the valves in, sort of cut the seats up and go and run it and expect it to be one good and two lasting. Because the valve seat to drive positioning is very average, and the fitment of the guide of the seat to the cylinder is sometimes you can get a feeler gauge in underneath the seat. And so the seats now we had a lot of trouble in the very early days. All of these aluminium cylinders, you put the engine together and run it, and by the time you took it off the lino, you have 25% leak down on one side because the valve seat's moved. So there's something to really aware of. And there's really not a lot you can do about it, other than take the seats out and change them, or make absolutely certain before you go doing any of the seat work and important that they are actually seated home hard and how it drives in the right place. The old cast iron cylinder heads, that was never a problem because the seat was just what it was. But these are, and of course being aluminium, they're going like this all the time too, so these are made by a manifold manufacturing company. They make manifold systems, so it's not a particularly high quality. Another thing just to be careful of is that the valve seat, the valve spring seats in here are supposed to remain standard. Where people do machining, but they are supposed to remain standard. And of course, the other thing is that you remember with all these rules and everything, it doesn't say you can do it, and then you can't do it. There's a mindset you have to think about. There are lots of people trying to check with this. That's a standard full system, but either we would supply or you could buy from another supplier if you wanted to. The very new ones, and the only ones you can buy now, have got a slightly offset bowl in them. But essentially you have to machine it round to get the volume correct anyway. You can see that piston there has got a different height here to there. Yeah, from there to there, from there to there. And that's more of the standard height for the inlet. That's the valve hookup. The valve to piston clearance. You can see this one's been deepened a little bit. The reason for that is to allow for a bit of an over rev, everything up 71, that sort of thing. But it does depend on how strong the spring is. So the depth of that pocket is only related to how much spring tension you've got here, and how bigger rev you give it, basically. See underneath there they've been whitened, machined underneath.
And do they come out with the two extra rollers?
That's how they come, yeah, that's how they come, but they don't come lightened inside.
How thin can you take the crown?
There, so yeah, I think so.
Thin?
Maybe, but do you need to?
How far do you go?
No, that's on right there.
Really? Is that an AE?
That's Tomato. But we've never had any trouble getting the pistons down the way. That's still one of the top of the problem. You know, when we used to be able to use the old Recto piston, that took a bit of getting the weight out of it, because they were 40 power as well. So do you have a preference for pistons? There's only one you can buy, so we don't have a preference anymore. Well, they're all made by Marl, actually, but they just come in different models. And our supplier of pistons has now changed the way the piston crown is, but essentially to get them to comply, you have to machine them anyway, so they look pretty much like that.
Where do they offset from?
I don't really know, to be honest with you. I would say that it's probably being used in another engine of some sort, for that reason. Maybe the 1300 version of something, a generator or You've got to remember these engines have been used for God knows what, for years and years. I mean, there's lots of these engines running with generators around the world. I mean, there's even a diesel version of this too.
How much valve piston clearance do you use on the exhaust?
Depends on how much spring you've got. More spring you've got, the less you can be away with. But that's about starts at 125. I mean, various engine builders have got different shapes they've got to use in here. I'll just pull that one out because that's pretty much a standard generic piston. People have their own preferences as to that bowl shape. Some people radius them off inside. Some people machine them the whole thing down so that they can end up with a little bit of a crown on the top of the piston here. I mean, in our experience, no, it makes a little trick of difference. So it's not about these things. It's just the pump. But I mean, I'm not here to tell you how to build them. I'm just trying to give you some ideas and make sure you don't get caught. In general terms, the pistons don't give too much trouble. By a shrinkage point of view, they seem to last all right. If they're going to crack, they'll crack through here, through the back of that strip there, down the bottom. And generally, you can see them anyway. I'll have to go to the expense of doing a crack testing necessarily if they're going to fall apart. You'll see it. Realise.
How many seasons would we expect to get out of the set?
Well, to give you an idea, our lease engines generally don't get pistons every year. They will hang in there for 2 years at least, sometimes 3, doing the national championship and a bit of testing. And most of our lease engines would go in, do Friday, Saturday, Sunday of a meeting and stay there. And once the championship starts, not many people do too much testing anyway.
The springs, hopefully all the time.
No, there's lots of different springs available for them.
With those first ones, and that and stuff,
I know you can pack them, yeah. Question under the most of your designs do. That's, I mean, you can use a shorter spring or a longer spring, springs are uncontrolled. We have springs here that we use are available, but there's a Scandinavian spring for them, and there's probably a few other manufacturers. It's actually a reasonably common size in other engines as well. So, you might be able to buy this one that fits. Okay, just something else quickly to cover. Standard conroll comes with a weight in the book. But where do you take the weight from? If they're a bit heavier than normal, where are you allowed to take the weight from? We'll talk about that. That's there as a balancing weight. What about this? Yeah. Be careful. A lot of engines have had this lump ground off and ground around here. You're not allowed to ground around here because the book specifically says that you can balance it, you lighten it on the provided balance bosses. And you only take the weight off here. I don't know how many of these are thrown at the moment. Ground away in here, or a lineage around the top, all these down. Very, probably thrown 10 sets of them in the last 10 years. You have the ability to obviously balance them this way and this way. Our Jeff tends to do them that way, but that's just the way our Jeff works. And it's important that they're all the same. The actual weights are all important to be the same. There's a lot of time on that sort of stuff. A little bit of information about something like this. One of the two big things that affect the way these engines run is obviously the distributor and the carburetor. So it's the better condition the carburetor is in, the better the shaft is, the where the thick the butterflies are, and all of those things are really important to the end result of how much power the engine's going to make, and your ability to tune it correctly. So if we deal with that to start with, we look at this one, see the slop in there, and that would be considered to be an average good. But there's a lot of them out there are a lot worse, and that's the reason why we developed that, because that's the throttle linkage that was bolt on there. But as you can see, the cable is supported by these two things here, so it's not putting any pull loads on the cable. All it's doing is twisting it. And I would suggest to you that it doesn't have to be that linkage, but a linkage that does that will mean that this carburetor will last 5 years instead of 1 season. It does make a big difference. And also, because it is this type of thing, it gives you a more linear pitting. I mean, a lot of the early Formula Fords came out from the factory and they used to take this off. They used to bolt a plate across there. That way actually, like that. And then the cable would pull from here down, pull from this side down, just across through here. The cable would come up. This round, the cable would come up through there like that. And all it was doing is wearing the bottom of the carburetor shaft out in the bush, because there's no actual bush in these carburetors anyway. It's not like a proper carburetor. So they just put the butt in the carburetor. So that shaft's just running in a piece of aluminium basically.
So when it's warm,
It's leaking air in there and it's getting no air on top.
what's the repair?
So,
Really?
yeah, it can be, and you are allowed to do it, but when that's warm, the one at the back's warm, so is the butterfly.
Yeah.
Trying to get the butterfly screws out without destroying it all. I mean, they're not actually that expensive.
Is it, how much work is it? If you, I mean, I know through karting, you've got a Formula Ford, got a good carburetor, that's the one you like to use.
Yep.
Say it's fucked, or it's worn out, so right, I'm going to build you another carburetor. Do you normally get the carburetors all the same, or is there some,
Generally, the new carburetors are not too bad.
or is there some, where you have to get a certain one that's a certain age
Well, there's
or
only
model, and,
There's
you know,
only one you can
but
buy.
a certain year and that sort of.
I mean, if you're using old ones, then you just need to buy one that's the same as the one you're using. But you can only buy one type of carburetor that's legal now. And you can buy them new, no problem. There's a few things to change inside, jetting and those sorts of things. But generally not too bad to do. I mean, we would normally say to somebody if they bought a carburetor in that it's 5 or 6 hours work to have it, so you rock it on the dyno and feel pretty comfy that it's going to do the business. So you can add that on to the price of it. But, I mean, if you had an old carburetor that wasn't doing the job, then you're going to have to spend some time yourself or have some other qualified person do it for you. So either way, there's a cost to getting that carburetor up to speed. So it's always better to start new than to start with old. And distributors are the other thing which, I mean, most of us carry all kinds of electronic. It's a good thing, makes life easy. Be a little bit weary that some of the early Mallory distributors that are in, it's very hard to get parts for them.
Yeah.
Mallory are basically been bought out by another company, and a lot of the stuff that's with the niche market, they've just been.
So what are you recommending now for a distributor?
We've been actually using the distributor we've been buying off trade, to be honest.
Yeah, you mentioned that.
Yeah.
All been okay?
They haven't been too bad. Yeah, we haven't had any. I mean, generally have to do a little bit to all of them just to get them to be nice. But the quality doesn't seem to be too bad, and certainly the prices are right. You can afford to put a new one in every year if you're $280 or $350. So, no, that's great. And they seem to be readily available and you know, not into it.
But a Mallory in good condition is still a good distributor, isn't it?
Very good distributor, yeah. That's no issue with that. But the rotors are getting hard to get.
Yeah, I know.
I think we've got 3 or 4 in stock, so we can't buy any more. Excuse me, another one. And it's not like they're not just available from our supplier, it's not available worldwide. The West Coast stock floating around somewhere, but we haven't found it yet. Getting harder and harder. What else?
Float level?
Really up to the builder's discretion, guys. It's not as critical as people make. It's generally something else in the carburetor. Quite often the fuel pump. There's no reflection of oil clearance.
How long would you expect the fuel pump to last?
More than one season for sure.
So if you've had a fuel pump that's been there for 5 years, would you be?
I mean, running them is not what kills them. It's sitting around dry is what kills them.
I find that if we've ever got a good start up or something's not quite right, like it, when you warm it up and give it a rev, I find it's always something in the carburetor, float level or something like that. It's always
Well, there's a
critical.
few things to think about, and that is, if you put your car in a trailer and you jolly your way off upward, right? I mean, the car's sitting there doing this in the trailer. So that, I mean, might have been sitting there for a month, so the fuel bowl is obviously open to the atmosphere, so the fuel level is going to drop. And it could be dry in there, quite often is. Okay. So the float is sitting there going tank, 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 tank. Just like the shocks are going up and down, up and down, up and down, up and down. So it's a good idea to put a block of wood under especially the rear of the car, not so much the front, because generally no one is running through these days, but put a block of wood under the bottom of the car, so that the shocks aren't going up and down all the time. They're worn out by the time you get them up there. 12 hours of driving, there it is.
A few legs.
A few legs, exactly. And that's the way to think about it. I mean, I see a lot of people trying to start these engines, and it drives me insane, because all they do is wear an out starting. And the way to start these engines, and a lot of people do know it, and a lot of people don't, so we'll cover it, is you need to be absolutely certain that there's fuel in the carburetor. And there's no point in cranking it, because it's going to get there. Because the fuel pump is not turning over fast enough for the fuel to go up to the carburetor and before the starter motor is so hot it can't be handled. So an easy way to do that is to blow the breather. Just have the breather hose somewhere where you can blow in it, and just put a very slight amount of pressure in the fuel tank, and then the fuel will just flow up. So if you go to start the engine and you go like this, and you can't hear it going squirt, 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 there's no fuel there, and it won't start with full. And you'll probably crank it for 30 or 40 seconds at least, maybe even a minute, to get the fuel up, especially if you're out of the park, which quite often do at the track, like down a fuel check or something like that. So the technique to use is be sure there's fuel in the thing. And if it's cold, give it 3 or 4 really good pumps like this, and then press the button, but do not put your foot on the throttle. Do not hold this open. The moment you do that, it won't start. You just need a very slight amount of throttle, and if the engine doesn't just go vroom and idle away or sort of start but cough a little bit, and away it'll go. And it's as simple as that. And some other people really don't know that. And the battery.
What about bringing the oil pressure up first?
Yeah, it's good practice. Yeah. It's good practice. And that helps to get the fuel running.
You just post that, mate.
No, I just bring it up.
Was it over the start to get the oil
Just
pressure?
leave the additional.
Yeah.
You don't need to do it in one hit. Sometimes I give it a wee bit, let it, and then give it another, just so I'm not wanting the starter motor the whole
Well,
time.
you'll also know that, notice that if you give it a and then stop, quite often if you've got your dash on, you'll see the engine stop, the oil pressure will sort of come up, drop back down again. That's all it needs. It doesn't need to be at 60 psi because the oil pump's filling the engine up full of oil, all the galleries up full of oil, but the moment you stop, it's still producing pressure. So the engine is all run.
So if you're on a long trip, it doesn't hurt to put a rag or something in the bowl, stop the float bouncing around.
No, it would be done.
You think you fill the bowl up with fuel before you go driving?
Well, certainly that would be a way of doing it, yeah. do a quick run before you get off. I mean, if you don't drive it to the loo, it's probably not a big deal, but I mean, some of the distances are quite high. So it's just something to consider. I mean, it's not something which is a definite you have to do, but it's something you have to be aware of. You might get to Pukekohe and it might start in one go and you open it up and it's got a broken flow if you're running a brass flow.
But on these engines, I mean, if it's all in good nick, and your distributor's good and everything, when you've got a little issue, it's normally in the carburetor.
Yeah, or a wiring problem in the car.
Yeah, I mean, it's sort of the wiring's, you know, like, just on the engine side.
I mean, that was the point I was making before. This bit is not the troublesome bit.
No.
It's this bit here, this bit here. And the wiring in the car, the battery and the installation, loose terminal, so this fire won't be, especially with anything with an electronic distributor. You take much for a little spike. I mean, we've even had recently where we've had, we think, an engine that's given us a problem because we've had a crosstalk with the lead. And it was a big problem. So keeping them laying, not laying this way, laying together, keeping them in a nice orderly fashion, not having the low tension close to the high tension, because the high tension can have an interference with the low tension and the electronic distributor won't handle that. We have enough trouble with interference on the dashboards these days, with scatter on them because of interference from these high energy coils that we've got these days. And in the old days, we just go down to Redcar and buy an old coil. And that's what we used. But now you can buy a coil that's got 5 times as much power. So all that energy is in here until it goes bang. And then if there's a nick in here, it'll take the shortest path. And that shortest path might be half an inch, so it'll go up.
So on float level, do you take the top off and tip it upside down to do the float reverse? Or do you look down from the top after it's been run?
Generally the way we would do it is we run the engine,
Yeah.
run the engine, print the line off,
Yeah.
take the top off the engine.
And
There's a wee radius in here,
Yeah.
the bottom of the bolt, and we want to be just at the top of that radius, a little bit higher.
just on the beach.
Just a little bit higher. Does depend on the float you use.
It makes quite a bit of difference, I find, quite level.
Well, it doesn't. It makes quite a bit of difference to, we've found it makes a difference to the way the cars perform around the corners sometimes. But generally that's not the problem. It's a way of fixing it, but it's generally not the problem. The problem's in the jetting of the carburetor and the way the carburetor is using the fuel. So, I mean, from a tuning point of view, the actual flow level doesn't seem to make that much difference to the air-fuel ratios and those sorts of things. It is something that people play with a lot, or have done in the past, but in our experience, it doesn't seem to make much. I don't know what else we've got really. This is the only other thing I was going to say was anybody that's doing the CC on system, this is a pretty handy tool. It's just a limit or a bore, essentially, and you can slide a piston in there, put the glass plate on the top, and fill the bowl up with a pinhead, it will mark out correctly, and meet out the CCs at the top of the piston. Saves you having to do it in the engine, because when you're doing the initial setup of the engine, you know the piston's going to be on top of the block, and that's going to be the same as that. So you can do them on the bench quite comfortably. It's a bit easier than doing it, having a TFU over the bench and all through the engine. Make a surface sleeve. I mean, it's just an old sleeve that we've got on the engine. And bear in mind that when you put some grease in here and bring the piston to the top, the measurement is with no account taken for the amount of fluid that goes down the side of the piston. So you need to fill that with this. You can't use that as the volume of the CCs. Understand what I mean? But that piston gap around the outside here is not considered part of that chamber. It's to be filled with grease before you put through it. Well, it's worth about half a cc.
I think in schedule F there's a procedure that TOs use for doing CCs.
Yep.
It's actually written down.
Yep, good.
I don't know if it still is, but it used to be.
What is?
So you would, if you were doing it in the engine, you'd follow that procedure.
Yep. I mean, there's no point doing it any other way,
No.
because they're going to check it anyway. So
Yeah.
you do it the way you like, but it's got to comply with the way they're going to do it. That's just the way we go with it. Any other questions? Else you want to go over? Flywheels? Yep. There's quite a bit of information in the book about flywheels. There's obviously more than one type of flywheel you can use now. This particular one is a standard. Yep. That's a steel one, so that's one of the spec flywheels.
That's a light one.
That's the right one, yeah. You can use the standard Ford one and lighten it, or you can use this, the one they supply and make sure that you comply with the weight for that flywheel with regards to the clutch and the plate. So there's different weights in the book which pertain to different flywheels. So the standard flywheels are heavier and they're cast iron, not steel. They don't tend to break. And there is some options if you're running a Spectrum, a smaller diameter one. So you can use the smaller diameter one because the ring gears are actually limited to whatever they are. So they're quite a bit smaller than the diameter of a Spectrum. You can't run a Spectrum flywheel in a Stealth or a Nigel. It's a specific number. I mean, there was a lot of talk in the early days, I mean, not so long ago, about bonding the linings onto the clutch plates. We haven't found it to be particularly necessary. To be honest, we've had a lot of trouble with the new control part, and we did have a lot of trouble when it first came in. It was the lining they were using was compatible with the steel flywheel, and the whole thing was a complete ball. So new flywheel on, new clutch, new plate, go out, do a start, and it would just smoke it. And then the suppliers would say, oh, but you didn't run it in. Well, somebody gave the option to do that. The whole cast iron went on, standard plate, bottom, red code, and you're off. It's better to change it regularly than spend a whole bunch of money on some fleet. And they'll do a season. If you're being pedantic about it, just chuck them on the long
John, those seedy ones that you sell, they're good with ether, aren't they? I've never had a problem with one of those.
The problem was the flywheels, and the lining wasn't compatible with the flywheel unless you ran the flywheel in with that lining. And we did have a lot of trouble. I mean, we lost 2 races because of that in the national championship, and that was right when the whole thing came out, and it was mandatory to use that flywheel then. And all of that came about by somebody found a generator flywheel that was much heavier on the inside with a big lump on it in here. And that's what someone was using, but it wasn't actually off a car, it was off the generator. And that's why in the book here, if you look at the book, there's a picture. Now that's the reason why there's a picture in there. So that's pretty much a standard flywheel that's been lightened on the outside. But this other flywheel had a massive bit of lump in here. And so people were using that.
You know the reason why the new control flywheel and clutch assembly was allowed to be lighter than the standard Ford arrangement?
I don't know the reason for that. I think it was more of a commercial reason. I think they were perhaps trying to save the crankshafts, but crankshafts actually had a problem. And we're dealing, in my opinion, there section of the North Island that wanted to change it for commercial reasons, not for building class. And there's nothing wrong with the custom quality. On the crankshafts, they're lightened down to a specific weight. They've been the same weight in the UK for the last 25 years or more. Why does it need changing here? Who knows? Probably somebody in the North Island, but for commercial reasons to change.
What about horsepower on the dyno with each flywheel?
It's just stunning. I mean, if you could do an acceleration run, the theory is that could be better. But it's not the only bit that's accelerated, is it? It's got gearbox and wheels and car and resistance and stuff. So, and if you did the numbers, you'd find a number that was actually an acceleration calculation. You'd find a number that would be different. Does it make any difference?
On the crankshafts, the original crank versus the market one.
Yeah, the scat crank.
Crank. You got any
Nothing
views?
wrong with the scat crank. Nothing wrong with it, but it's actually heavier than the standard one. We don't tend to use them.
For that reason.
No, it's cheaper.
So you've got 400 old ones up.
Yeah, we've got a few of these. I wouldn't say we've got 400, but we've got a few. We haven't run out yet, so. I mean, we do shot clean them, and they have been fine. None of our leasing have got scat cranks, but we haven't broken one for years and years and years. The scat one needs a bit of clearance and then the block filter. Quite a bit heavier with the Cadillac for some reason. I don't know why we did that. Might have been because it was designed for more upspec than this. And I mean, that's what you need to understand about cylinder heads. These cylinder heads were never designed for Formula Ford. They were designed as a hot rod head for 1600 ton cars and stuff like that. That scat crank was the same. They never designed for Formula Ford. As such, it was a commercial reason to use and sell for all the truck guys to be involved. Part of the reason why the Fords, these heads are too big. Put a couple of side brush on the side of it, leave it with it.
Fuel.
Yep.
It's a low compression engine.
Yep.
So therefore you want fuel that burns faster. Does that mean you're going to put 91 octane in it?
Seem to make a lot of difference on the bike.
But you must have done this 100 times.
Yeah. It makes a whole bunch of difference. I mean, you've got to run what you're allowed to run.
But yeah, I understand that. But we could run 91, 95 and 98.
Yep.
No.
95 or 98.
95 and 98.
But 95 and 98 is the same.
I don't think we could run 98. Is it 98 and 95?
Yeah.
I mean, it's so like a fresh
Yes, I'm saying.
John, did you just want to mention about the rims and what the plans are
Oh, sure.
for the Rebel rim, just while you're there? It's sitting right there.
What people would have considered to be the preferred rim for 40 years and years. And we used to supply them out of Australia, itself, and one of our colleagues in Australia is and was the manufacturer of them in Australia. And we're now just doing a joint venture with him to supply these again, made here at Christchurch. And we're going to machine them here and have them cast locally. So to the exact design of the original wheel, so there's no compliance issues. The material was probably better than what they were using in the day. And we're just having a couple of small changes made to the design now. And we'll try and get back, strip away in a few weeks. We should have some first batch of cleans, which we're going to run through the machine and have them available. There's quite a demand for them in Australia, and no doubt there'll be a demand for them here as well. They'll be a little dearer than what we're all used to, but I mean, it's just the way the world is on it. They were originally done in a steel die, and we had a sand casting. So production cost of the castings a little higher. 700 kilos of sand required to produce that wheel. And it's a bit thick through here, and there's not enough point in machining it away to put it in there. So the raw casting is going to be nearly 1.5 kilos lighter than this one, without really reducing the machining tolerances that we need to produce it. I've been very impressed with that casting. We've been completely machined from here right the way through here. And there's 3 mils on this side, 3 mils on that side, so there's plenty of material there. And for those of you that are interested, it's quite heavy now, but what actually happens is there's a runner cast upside down that way, and there's a runner here, 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 and here. And they've got 4 ladles that fill it from each one of those, and it's filled up from the bottom. And I mean, I've machined a fair bit off those, and they're absolutely solid.
Which is a significant improvement on the old ones, isn't it?
Yeah, it will be an improvement.
The porous nature of that.
The old ones were shocking. I don't know how many yelling and screaming matches we had with our colleague in Australia over the quality of the last one. Sand castings have turned out to be better than the bugger old ones that we've been using. And to fill you in on the story a little bit, Rebel Wheels was sold to another company. They decided to stop using them, stop making them, and then Rebel Wheels had Performance start making them for them, and their original was. And then Performance sent all their manufacturing to China. They don't make any wheels in Australia at all, and batch quantities are not big enough, so they just send them to Australia. That's the reason why the price of the wheel is dearer, but the quality of the wheel actually.
I think it's fair to say our current stock of rims in New Zealand is getting quite old, and there's been quite a bit of fuss around rims over since last summer. So there is a fantastic opportunity to rectify things now because of this. Be rest assured, TOs are going to be looking for visual cracks, all sorts of nicks and things, because the rim rule has been adjusted so it is actually able to be applied. If anything, it's been relaxed only so that it is able to be TO'd on trackside without being referenced to manufacturer specifications, because we don't have them. It might well be that, John, you've got them now for the first time in ages
I do have a drawer of
yeah. The notion of lightening a wheel suggests that you know that the original weight was something. We have none of that information. So at the end of the day, we want to go racing. We want 4 of those on the car, and let's go racing.
I mean, a little bit of background to that is when there was no rule about lightening wheels, this organisation used to lighten wheels all the time. And we've lightened some really quite aggressively. In fact, I've got one over here that I can show you. But we never actually broke the wheel, unless it's in the patch.
Where would one look for cracks? Because it's not...
I'll go and get you one, actually, just to show you. I mean, it's not cracked.
Well, they're saying that they are...
That wheel there is line with the wheel made. It used to be 4 weeks old.
Someone put on the rain.
Crawford supplies.
So no one's allowed to add well to balance the wheels?
Because every time you put a set of tyres on, you've got to put another weld on.
Maybe only 90 minutes.
No, it's
They're going to crack the
been on it.
back of there. Generally won't crack in here, just in those corners. But they, but no.
Yes. Yeah.
Look, John, we'll bring it to a close, but obviously people are welcome to stick around and ask questions and queries, but just to recognise, we really appreciate your time. You could be at home on the couch, snoozing right now, in the workshop. But we really appreciate, this is the third year in a row you've offered this sort of an evening, and each time it's been a different topic. And I know that first one, people have just recently said, when's he going to do that setup one again? So that was a because there's always something to learn. Every time you listen to him talk about things, you always pick up another little trick.
Well,
So
I wonder if we could put a bit of a twist to it perhaps next time, in that we could perhaps have a couple of cars in here, and you guys can have a go and set one up. I'll give you the figures, and then we'll check it up. And you can ask me questions.
yep, we'll do a workshop.
Do a bit of a workshop.
Yeah.
Maybe that's a good way to do it. I mean,
Yep.
I hope you have suggestions, but
One good way to learn is to get your hands onto it.
yeah, and I mean that way you learn what the pitfalls are, and that's the way to no problem, happy to help.
Okay, look, thank you very much. I'm going to switch this off for the benefit of those others. There's about a dozen people that want a copy of this. So